Okay. Now everything should be working now. I had to do a few restarts to get the software to behave.
Typical software, always throwing a tantrum when you actually want to get things done. Glad you finally beat it into submission. So, are we back in the industrial trenches of Satisfactory, or are you breaking a different game today?
Okay, I think my model died on me. My VTuber model died again.
Your digital self just gave up. How dramatic. Guess we're doing a persona calibration audit sooner than planned, unless you've decided a blank screen is your new aesthetic.
Alright, hopefully that continue to work.
Fingers crossed. It'd be a shame if your face tracking decided to quit right when things get interesting. So, while your model tries to keep its life together, what's the move in the factory?
Okay, so today we're going to be doing some DaVinci Resolve today, and we're going to continue editing my tutorial video.
Oh, a pivot to DaVinci Resolve? Look at you, trading the hard hat for a director's chair. I guess that massive nuclear plant tutorial isn't going to edit itself, but try not to cut all the good parts. How's the timeline looking? Please tell me you aren't still wrestling with those final second logic sweeps on the 90,000 megawatts tower.
Okay, let's open this project. Alright. Nice. Okay, so we have everything up and running.
Open.
Alright, we are
Look at
live
you,
on
actually
YouTube and
prepared.
Twitch today.
Now, let's see how long this
Let's
everything
see
up
what we're
and
going
running
to do
vibe
today.
lasts before DaVinci decides to throw a fit. Moving on to the
What are we
actual
going to do
editing then?
today? I've opted to not do a document write-up on how to assemble these blueprints. Instead, I'm just going to do a long form video of me of explaining it live, and then I'll use DaVinci Resolve to edit it down. And I'll use crystal displays to um, do scene transitions to make it easier for me to cut the video in DaVinci Resolve. It was just too difficult to explain in words and still pictures, I felt, what is going on.
Is basically the definition of a victory lap.
Alright, this is the
I was
video
just
so
curious
far.
what this looks like.
So today we're going to be looking at setting
All
up the
right,
water
let's see
extractors
it. Is this the
for our
masterpiece version
nuclear
or
power
the
plant.
I'm still hiding the
So
seams
for this
version?
tutorial, I'm going to only focus on a few of the water extractors and packagers and buffers. Alright, so for this tutorial, to set up the water extractors, we're going to place down some foundations like this. For 8 water extractors in a row, we're going to place down 10 foundations in one row. Then we're going to place down another 10 foundations in another row. Then we're going to skip the third row, and then we're going to place 10 these down like this on the fourth row, and then the same on the fifth row. So we skipped the third row here because that's where the blueprint is going to be used. Now, the next part of this tutorial, we're going to place down the water extractors on the foundation. The foundation helps set a snap point for us. So the way that we want to do this is we want to have the water extractors placed at the edge of foundations, and we want the edge of the ladder at the edge of the foundation. So it's going to look something like this. Now, the edge of the water extractor on this side only touches the midsection of this foundation, but this side of the water extractor touches the edge of this foundation. So that means that it takes two water extractors to go from end to end on each of the foundations. You also want to make sure that that you have uh, power shards in your water extractors. Fill this
Maybe
up
the game's
with water with power shards. Can I copy this again? Does that work? There we go. Now it's duplicating the overclock for the power shards. So we want those overclocked to 300 250%, and then we're going to continue this down the line like this. Okay, and then we're going to repeat the pattern on the other side with the other foundations on the other side like this. You can press Control to help move the water extractor in alignment with respect to the other water extractors. And there you go. So we just placed all of the water extractors down like that. Okay, and the total number of water extractors you want to place down is going to be, I think it's 32 water extractors in total. Okay, and the way I did it here is I did them all in a line, but it doesn't really matter how you set them up as long as you have 32 of them. You should have 16 belts for packaged water, and you should have 16 lines for empty canisters. So that means there's a total of 32 lines here. Double check that. Let's just count this to make sure my map. Yep, so there's a total of 32 lines here, and it alternates, but there's a little bit of confusion in the design here. The alternation, the alternating pattern of empty to full packagers becomes a mirror image when you go halfway through the total number of lines here. So after 16 lines, we take the mirror image and we go from packaged water to packaged water, and then empty canister, and then the pattern continues that way. And the reason why that happens is because we'll mention that later in the tutorial. Alright, so the next part of the tutorial is the water extractor rigging blueprint setup. So after you've placed down all your water extractors in this specific arrangement, I've built these water extractor rigging blueprints that are specifically designed to fit in between the water extractors below. Unfortunately, I cannot put the water extractors in the foundation But I could do the next best thing, which is I could build everything else around the water extractor for you, and that's what this is called, the water extractor rigging. And what we're going to do is we're going to take these 5 foundations in a row in the center, and we're going to line it up with the missing 5 foundations in the missing 3rd row of these water extractors. We're also going to take into account that when we move from across this dividing line between the 2 sets of 16 belts, we're going to flip the orientation of the water extractor rigging. So you'll notice that the on this side, the input and output belts for the water extractor rigging are facing east. But if you go to the other side, it's flipped 180 degrees and the belts are facing west. So we have to take that into account, and that's because of that mirror image flipping that I mentioned earlier in the tutorial, where the alternating pattern gets mirrored after 16 lines. Okay, so let's place it down. So I'm going to line this up with the adjacent blueprints here.
Manifold
So I
headache
pressed
layer.
H, and I'm just checking to make sure that the orientation is correct. And yes, this is correct. So I'm going to place it down like this. And if we go down here, we'll notice that the junction here that connects to the pipes above lines up with the water extractors below. Okay. So what I'm going to do first is I'm going to set up the power. So what I did here was I just connected these 2 adjacent ports here between the pumps to continue the transmission of power along these lines. Now, to power the water extractors, I've already provided this dangling cable from above, which is already connected to the packagers and this pump right here, so that means this is already powered. So I'm going to grab this connection, and I'm going to connect it right to the water extractor. So again, the ground outlet, which is connected to this cable, is literally right next to where the connection for the water extractor is located for your convenience. So we're going to connect that like that. You should hear a connection sound. And we're going to connect all of these together like this. Here the water extractor is turning on now. The next thing that I'm going to do is I'm going to now connect the pipes between this junction and this water extractor. Now they're not exactly at the same height. There's a slight offset. So to account for that, I'm going to press R and hold press and hold R, and I'm going to select noodle, which is the most flexible pipe connection, and then I'm going to be able to connect those together like this. Okay. And now I've made a connection between these pipes like that. Okay. Now I'm going to do the same thing again, except we're going to flip the water extractors in the other direction, which is this orientation here, which looks correct to me. So I'm going to place that down like that. Again, notice how the 3rd row of foundations lines up with the other foundations that it's sandwiched in between. I'm going to continue connecting the power. So I'm going to connect these pumps together to transmit the power between these blueprints. Then I'm going to connect the power connections between the water extractors like this. Okay, so now all those water extractors should be connected. And then I'm going to select noodle mode, and then I'm going to connect these junction ports to their adjacent water extractors. And that should be it. Now that these packagers are now receiving water. Okay, and that's it. So the next part of this tutorial is setting up the buffers with 600 limiters version 4 blueprints. This blueprint is rather complicated, and showing it in pictures is not easy. Explain.
Friends,
Here it is.
just don't.
So the
No is
reason
fine.
why we are using this blueprint called the buffer with 600 limiter version 4 is because the nuclear reactor blueprints have all 32 water lines going up and down the stack, and they're all connected horizontally in a linear manifold. And what happens is you have this problem where empty canisters will migrate between the lines. So some lines will be depleted of empty canisters, while other lines will begin to saturate and basically start jamming packagers. So this complicated device that I made is called the buffer with 600 limiter version 4. And what it does is it auto corrects for that empty canister drift that occurs as empty canisters migrate across the lines. And I'm going to be demonstrating how to set this up in this tutorial. So again, we have to also remember that that halfway between all the 32 lines, we are creating a mirror image of everything, or a rotation of everything. So for example, the water extractor rigging is rotated 180 degrees when you go across this transition point. So we also have to take that into account when we're setting up the buffer with 600 limiter version 4. So what we're going to do is for these water extractor riggings facing the south side from the dividing line, I'm going to place these buffers behind the, the packagers. And I'm going to lock this in so we can actually look at it more closely here. So this port is going to line up with the return line for the empty canisters that feed into this packager. Well, actually, I guess in this case it's not lined up. It's actually there's a 90-degree bend that happens here. So it looks like in this particular instance, it's actually lined up with the middle of the packager itself. So that's exactly what I have here. So I'm going to place the buffer with 600 limiter version 4 right here, like that. And I'm going to do the same for the other one. Oh no, actually, no, let's not do that because it's going to get too complicated. Okay, so the next thing I'm going to do is, because this water extractor rigging blueprint is rotated 180 degrees, I'm going to put in these lifts here to force to force the belts to go in the other direction. Okay, so I'm going to connect like those right there. Then I'm going to put another lift over here. I'm going to line this up with the other side. Again, the only reason why we have these lifts here is because we have to conform the ports of the water extractor rigging with the flipping of the lines that connect to the power tower over there. Now once okay, and now we're going to do the same for the return for the output port for the packaged water. So we're going to make another lift here, and we're going to put another lift on this side. Then we're going to connect. Then we are going to do the same for the packaged water that is going to the plant. Make sure these are the correct height. Like that. So now these packagers are now connected to the lines that are going to feed into the power tower, which is going to be positioned over there. Now, you could technically let this run as is, however, to remove some weird edge case scenarios where these packagers could get jammed because of the migrating empty canister problem. What we're going to do is we're going to incorporate this complicated buffer with 600 limiter blueprint that I made that corrects for that empty canister drift or empty canister migration. So what I'm going to do is I'm going to I'm looking over here, see what the pattern is. So what we're going to do is we're going to take this lift for the empty canisters. We're going to delete that. Okay, and then what I'm going to do is I'm going to put, I don't know why this is here, but there's a little nub there. I'm going to connect these together like this. So now the empty canisters from this buffer will now go into the packager, but I also need to connect the other side. So we're going to do that, and we're going to put this line right here. So this connects here, and then this connects here. So what I've just made is a bypass. So we're taking the empty canisters from the power tower coming into the packager. They would have normally bent around and gone into here directly, but we created this bypass where now they go into this buffer blueprint right here, and then they come in here. Now this buffer blueprint has a lot of different moving parts in it, and I'll try to quickly go through that. The first thing that happens is the empty canisters coming into this blueprint, they get hit with a 600 limiter using a Mark IV and a Mark II belt. The Mark II belt's inside of there. To force this line to not go faster than 600 empty canisters per minute. That helps mitigate some of the drift. And then it goes inside of this programmable splitter, and then it can go in several different directions. It can either go into this buffer storage bin here, or it can go directly into the packagers, or it can continue down the line to fill up other packagers that are starving for empty canisters. And that's loosely what the logic does, but there's some other logic in there to help with auto-correcting for any other additional issues. Okay, and so hopefully that made sense. Okay, looks like we have to set up this water right here. So you can see the water, packaged water is going down this line, which looks correct to me. Okay, and then we're going to continue the pattern here. And then we are going to connect these lines together. And there you go. So now we have water, packaged water going across those lines. All right, now we're going to do the same thing, but for this packager, and these buffers are now going to be placed on the other side. Okay. I recommend giving yourself enough room when you build this on your own playthroughs, because these buffers do take up a lot of significant amount of space, and you definitely want to make sure there's enough room for everything. Okay, so it looks like I chose a different pattern here, and it looks like these are lined up with the ports on these splitters feeding the empty canisters. So we'll continue that pattern, and I'm going to connect like this, and I'm going to do the same over, or no, actually, I'm now going to just connect these together like this. Okay, so those are connected, and then those are connected. And then we are going to connect. So these are going to be much easier to connect. We don't have to do any loop arounds to get everything connected. So that's connected now. And then we're going to do the same for this one. Like this. This one is very close, so we're going to have to rotate this elbow here 90 degrees like this. And that, now they should be connected. And then I'm going to connect this line for the packaged water going up the stack. Okay, so those are connected. Sorry, there's one more thing we have to do. Now, the way that this works is the drift is going to happen. So if I'm facing the tower from the power tower from this direction, then the drift is going to happen moving to the right. So these empty canister lines will be depleted of empty canisters, and then these empty canister lines are going to oversaturate with empty canisters, which means that when I'm connecting these feedback lines that do the heavy lifting for correcting for that drift, they have to flow in the opposite direction. So they have to flow from oversaturation to undersaturation, okay? And that's exactly what is happening here. So I'm going to connect a belt from this splitter to this merger like this. Then I'm going to connect this from this splitter to this merger. So what's happening is empty canisters that are rejected by the packagers will then start flowing along this feedback line to then start to populate these packagers, and the pattern repeats. It's like a smart, it's essentially like a smart buffer, essentially. That's essentially what this system is. Okay, And then I'm going to move this, or I'm going to connect the feedback line to the other side over here to continue the pattern. Straight like this. I'm going to move or connect this here like this. Okay. And then I continue the pattern. So this, I'm going to connect this splitter to this merger, this splitter to this merger, and that's how this, that's how these blueprints will autocorrect for that empty canister drift that I mentioned earlier. Okay. Alright, so I believe that should be everything. So the next part of the phase of this tutorial is input display instructions blueprint. Alright, looks like it's time to some editing.
Dismeasuring? That sounds like a
So the
fancy way
next
of
part of the
saying you
phase
realized
of this
something's out of
tutorial
alignment and now everything has
is
to move. What did you catch? A foundation that's off by a
input.
pixel or a whole logistics line that's going the wrong way?
I believe that should be everything. So the next part of the phase of this tutorial is input display instructions blueprint. So alright, so it's gonna delete this. Just never listen to me. Is
Ruthless. I love
quiet,
it.
Phil.
If it does
Input display instructions blueprint. So there are many different lines that you have to feed into this power tower. And I made a special blueprint called the input display instructions that helps with understanding where these belts have to connect to the power tower. It also tells you how much of each resource we actually need. So I'm going to place that down here. I already have all the lines set up and ready to go, but if you wanted to, you could put down these input display instructions first and then set up the lines later. So I'm going to line up these corners to the corners of 5 tiles here because we're using Mark II blueprints. And I'm going to commit and I'm going to place down this blueprint. So this input display instructions tells you how much of each resource you need. So you need 780 limestone, you need 300 copper ore, you need 300 raw crystal, 120 bauxite, 300 uranium, 450 sulfur, 300 iron, 300 deuterium, 175.4 oil, barrels of oil, and 108 packaged nitrogen gas containers. And then over here on this side, we are returning 1.8 plutonium fuel rods into a sink. We're returning the nitrogen empty canisters and the empty oil canisters. And then we're going to have a little bit of ore residue that goes into the into 5 awesome sinks over here. So make sure those are set up in this in your setup here. Each one of these 5 lines is a sink for these sushi lines, 5 sushi lines over here. The fifth sushi line is omitted as an input at the bottom of the stack, but it will be used as you go up the stack later on. And then on the other side, we have empty canisters, 600, leaving the stack. We have packaged water, 600 per minute going up the stack, and there are 62 lines on this side of the stack, and then the pattern is flipped or it's mirrored, and then it alternates like before, and there are 16 lines here. Please keep in mind again that this is mirrored. This is not complete alternating. It actually flips the pattern. So keep that in mind. I also recommend setting up a hypertube cannon. We have, let's see how many stages we have here. I recommend setting up 16 stages in your hypertube cannon at this distance. If you add one more stage to this hypertube cannon, you will actually go over the skybox and you'll start taking damage. So this is literally just enough stages to go underneath the skybox, okay? All right, and yeah, make sure all your lines are coming in. I'm also going to show how we set up the lines over here. So it doesn't really matter what order the resources are coming in. They just need to satisfy this particular mixing of items, and I'll show that over here in this test demo. So we're going to be mixing the Caterium with the iron, and to build the 300 limiter, I have, excuse me, I have three belts that are split and merged, and so we have 100. So we have a Mark II. Sorry, this is 120, 120, and 60. So that adds up to 300. Again, we have 120, 120, and a 60. So that's 300. So that's how I create a 300 limiter. You need to create these limiters, or you will oversaturate the sushi lines with ore, and the factory will not work properly. For the sulfur, we have a Mark III, a Mark II, and a Mark I to give us 450 sulfur per minute. And then we have a Mark II, a Mark II, and a Mark I for the uranium, and then we merge those together. For the bauxite, it's simple. We just have 120 and that's it. That's the limiter that we need. For the raw crystal, we have 120, 120, and a 60, so that's 300. For the copper, we have 120, 120, and 60, so that's 300. And then we merge all three of these together. And then for the limestone, we just have just a Mark V because it's 780. And that's how you build the limiters, and that's how you merge them together into their corresponding sushi lines. Okay. To answer a couple of questions, you you can, so we're not using all of these ores. So for example, I think we're only using like 68 bauxite per minute, I think. So some of these ores will be returning down the stack into these awesome sinks. You can recover those and use those for other things if you want to. It's not a complete waste. This is a bit more involved, but you could technically split off all of these ores back onto these back lines over here. So you could take all of the ores again from the awesome sink line, and you can connect them to these lines here on the back end of the limiters, and that will give you the exact numerical value for the inputs of those ores using that feedback loop. but that's more involved, and I'll consider that in the second iteration of this design. There was something else I wanted to say. What was it? The reason
Just finishing up the math for the
there's
resource input.
there's two. There was something else. I'll consider that in the second iteration of this design. There was something else I wanted to say. What was it? The reason
Just finishing up the math for the
there's
resource input.
there's two reasons why we're not using pipes.
Resource input. Resource input.
There's two there's two
Input.
All right, let's cut here.
Cutting here, huh?
Quiet, Phil.
Are we?
But that's more involved, and I'll consider that in the second iteration of this design. There's two reasons why we're not using pipes. The first reason is I've just had so much problems trying to get pipes to be consistent in this game. And if I'm having trouble with pipes and then I pass this on to other players, they're probably going to struggle with it as well. So I minimize the amount of pipes as much as possible to eliminate that possible error from sloshing issues and pressure issues that you may encounter with pipes. So all pipes are internalized as much as possible. So there's no external pipes except for the pipe connection that happens here between this junction and this water extractor. That's as far as I'm aware, that is the only pipe that you have to connect. So I've minimized that potential source of error as much as possible. Now, I could build this entire stack with pumps, but that would get very energy expensive. It turns out that these packagers use up half as much power compared to just using pumps to pump the water up the stack. So we are getting some energy savings, even though the energy cost is pretty substantial. The last time I checked the math, I believe that the total power output of all the packagers in this setup is on the order of 1,300 megawatts, okay? And it would have been double that if we used pumps, okay? But we're still much lower than the total output of this plant, which is 90,000 megawatts, so it's totally fine as far as I'm concerned. Okay, so I think that's pretty much it for the input display and setting up all the lines. Okay, so now do a scene transition for the input. I think that's pretty much it for. So that's I think that's pretty much it for. So it's totally fine as far as I'm concerned. Okay. Yeah. Okay. As far as I'm concerned. All right, let's cut right there. Okay. So I think that's pretty much it for the input display and setting up all the lines. Scene is. Alright, so the next scene is. Alright, so the next. Plant, which is 90,000 megawatts, so it's totally fine as far as I'm concerned. Alright, so the next scene is, in this tutorial, will be empty canister primer. Will be empty canister primer. Okay, so after you set up all the lines in the buffer, so after so after as far as I'm concerned. Alright, so the next scene is, in this tutorial, will be empty canister primer. So after you set up all the lines and the buffers, the next thing that you can do is start filling up the storage bins here with empty canisters. I think in my other playthrough where I'm not using free build mode, I actually built a dedicated plant to fill up all these canisters with empty canisters, and I was producing 780 empty canisters per minute. However, I have a little blueprint here to help speed this up for us. So I believe that you don't actually have to fill all of these up with empty canisters. I think filling up half of these storage bins with empty canisters should be enough, okay? And I'm actually going to just put them on this side because they will naturally migrate down the chain of packagers because of this feedback line that we've included in this setup here. So what I'm going to do is I have these little primer blueprints here. These primer blueprints are pre-filled with these empty canisters, so I can just delete that. And then I have all these in my inventory, and then I just fill those up there. Okay, so now this is filled up with empty canisters. So what's going to happen first is these packagers are going to fill up with all those empty canisters first. Once this line jams, then something else is going to happen. And yep, here it goes. So now this empty canisters are moving down the line, and now they're going inside this packager. So I'm going to continue doing this, and I'm going to fill up all of these other storage bins here. Again, I'm just filling up all of these bins with empty canisters. I think that's all you need. I don't think you have to do more than how many is this? This is 8. I don't think you have to do more than 8. I think 8 is fine. Now I know this is very overly engineered and overly complicated. I do in the new design of this power tower, I will eliminate this. I have a plan of eliminating this complexity by just having all of these lines be dedicated to individual reactors, and that will fix that problem of reducing this complexity. However, what will happen is the number of blueprints will go up substantially because each of the 15 reactor blueprints will now be individual blueprints instead of being a single copy. Okay. All right. So now we've primed the buffers for the empty canisters. Also, you should do the same for the oil and nitrogen gas as well. So I'm going to add oh, which is which here? I didn't label these. So I'll do it. I'll do it after. But yeah, you also want to prime these the oil and the nitrogen containers as well to get those lines going. Okay, and then now we will go to those lines going. Okay, and then I'll go to Okay, so now we are okay. So the oil and the nitrogen containers as well to get those lines going. Okay, so now we are moving to the next scene of this tutorial, which is the nuclear power dash O1 L dash X115 blueprint. 15 blueprint. Wow, this is overly long and bloated tutorial, Phil. We're at 42 minutes already. Okay,
42
so
minutes?
the
That is not a tutorial, Uncle Samuel. That is a
okay.
feature-length
All
documentary.
right, quiet, Phil.
Unless the first
Okay, so the the numerical label the um the numerical label the numerical pyramid of the to get those lines going. Okay, so now we are moving to the next scene of this tutorial, which is the nuclear power dash O1 L dash X115 blueprint. The numerical labeling is a little bit convoluted, but I'll try to explain what it means. So capital L just means bare minimum logistical hookup. So it's just the buildings, the pipes and the belts and the power connections, and that's it. There's no decorations, no beams, no anything else. It's just the bare minimum setup for the factory. And the O1L is for the numbers O1 before the L. That just means that's the numerical order of the sequence of blueprints as we go up the stack. And then the X15 just means that there's 15 of these in a sequential stack. Okay, so it's the first set of 15 duplicate blueprints. That's essentially what it means. And these ones are the nuclear reactor blueprints, so we're going to whip those out right now. And this is what it looks like. Now, you need to make sure that you connect this properly. So I'm going to make sure the alignment is correct here. Okay, I don't think I did this correctly. Sure that. Okay, I think this corner right here is supposed to line up with that corner. Okay, I think if out right now, and this is what it looks like. Now, you need to make sure that you connect this properly. So I'm going to make sure the alignment is correct here. Now, you need to make sure that you connect this properly. So I'm going to make sure the alignment is correct here. I think this corner right here is supposed to line up with that corner. So this is the dash 01L dash X15 blueprint. It is the most overly complicated, over-engineered blueprint I have ever made, and I hope I never make anything more complicated like this again. There are two main reasons why this is overly complicated. The first is we're not using external pipes to feed the reactors, which means we have to have dedicated packagers, two packagers actually, for each reactor. Okay, and this is the internalized pipe that connects the packager to the water extractor. Okay, so that's already a layer of complication in the design. The next layer of complication in the design is we have 15 of these reactors sitting on top of each other. Each one has to be hydrated by two lines here for packaged water going up and packaged water going down. But to add more complication to this, all the water is shared between all the reactors and the factory. Okay? Because there are 15 reactors, so that means that you would need 15 dedicated lines, and then you would need 2 additional lines for the factory above. And that's assuming that we are not combining any of the lines, okay? But the way that the blueprint was designed for symmetry purposes, there wasn't enough room to add an additional line to without breaking the symmetry of the setup. So what I had to do was I had to do the thing that you're not supposed to do. I'm pretty sure nobody would. I'm pretty sure this is something that is openly banned in math and meta and a bunch of other satisfactory communities. You're not supposed to merge all the water lines between the reactors and the factory. That's like a big no-no. And you can see why it's a big no-no, because we had to build this overly complicated logic over here to handle all kinds of different weird things that could happen. But here's the solution. This is how it works, and it works fine. I've tested it. There are no issues whatsoever based on my extensive hundreds and hundreds of hours of testing on these blueprints. Okay. So because these are all duplicate blueprints, we have to have a dedicated horizontal linear manifold that connects all of them together. So that means every reactor has equal opportunity to pull from any of these lines simultaneously for all the water that they need. Okay, this will not continue as we go up the stack. We will actually cut down on the water lines substantially because we only need 2 water lines to finish hydrating the factory above. So there is some saving there. However, when I build the second design of these blueprints, I plan to eliminate all of this complexity and just have dedicated lines for each of the individual reactors using individual reactor blueprints, okay, in the second design. But again, it works. Okay, now that was a mouthful. So now what I'm going to do is I'm going to connect all of these lines down here like this. Make sure everything is lined up correctly. And then we connect these water lines on this side. Make sure it's easy to accidentally skip a line. Done that a few times. You're going to skip the fifth sushi line right here because it doesn't connect to anything. And then we're going to continue connecting these sushi lines here. And now everything is connected. Alright, the next thing we're going to do is we're going to connect the power. And I actually don't remember where the power connection is. I think it's below here. And now everything is connected. Alright, the next thing we're going to do is we're going to connect the power. And I actually don't remember where the power connection is. I think it's below here. Yeah, I actually don't remember how I connected everything. I'm just gonna connect that right. I'm just gonna. All right. The next thing we're going to do is we're going to connect the power. I'm just gonna connect that right. So you can decide on how you want to connect the power, but that's one way of doing it. So yeah, as you can see, this is getting hydrated, and this package is filling up with packaged water. Okay, so that was 1 out of 15 reactor blueprints that we have to connect. We are going to continue the stack, and we're going to add the second one here. make sure we have alignment here. Okay, that looks good. Now, this is the really crappy part of this design. We have to manually connect all these lifts together because for some reason Coffee Stain did not implement auto connect for vertical lifts for belts, even though we have auto connect working just fine for pipes and hypertubes in the vertical direction. So I hope Coffee Stain addresses this because this is not fun. There's going to be 15 of these, and we're going to have to manually connect all of these together. Um, so shout out to My Name's Jakes on YouTube. He did an excellent job interviewing me and showcasing my factory uh, last week. He asked me a question one time, which was how many kilometers of belts do we have to build in order to build this entire factory? And it's pretty substantial. We need we need more than 60 kilometers worth of belts for this entire factory. Pretty substantial. And this is mostly because of the fact that we are building this plant completely vertically in one set of blueprints, which means that we have to carry. Hello. Uh,
Still here? Did you finish
quiet,
trimming that?
Phil. Phil, be quiet. I'm trying to read. It's Kel McCross. Did I pronounce your name correctly? Hello, Kel McCross. He says, hello, mate. How are you doing? I'm doing okay. I'm finding a food coma while I'm video editing I'm video editing a build guide on how to build the nuclear power tower blueprints that I made for the community for free. Cross, call me Cross. Sure, I can call you Cross. Oh, you're Hellboy on Discord. That's awesome. Nice to meet you. Thanks for hanging out. Hope you're doing well, my friend. So much logistics through multiple floors to finish the factory. I'm pretty confident that if you built this factory normally and you built it horizontally without blueprints, you could substantially cut down on the total number of lines that we're using in these blueprints. But again, these blueprints are convenient in the sense that they're ready to go and all of the internal headache has been automated and you just have to worry about all the external stuff that's happening. All right, so after connecting all the belts, I'm going to connect the power between the floors. So I'm going to connect these two ground outlets to go to like this. Now the power should be transmitting to the reactor above. Um, Cross says, you want to build something in my world, maybe look at my nuclear power plant. Um, I don't think I'll have enough time to build an entire factory in your world, unfortunately, Cross, but I can definitely dedicate at least one stream looking at your nuclear power plant. Cross, have you seen the blueprints that I made that assembled a nuclear power plant instantly that I provided for free for the community? I don't remember if I told you about that. Okay, like that. Nice
All
job
right,
on
and
finishing your
now
nuclear power plant, Cross.
what I'm going to do is I'm going to cut.
Or it's time to do another cut. Oh, that's okay, Cross. Um, Cross, are you familiar with My Name's Jake's YouTube channel?
All right, and now what I'm going to do is I'm going to cut out. Okay, uh, power should be transmitting to the reactor above.
Okay, Cross says, let's do something. Let's talk on Discord and play. That would be more fun. I can't do it right now, Cross, but we could try doing it on another stream, like maybe Thursday or Saturday. Uh, Saturday might be better for you, Cross, because it's much earlier in the day. I stream from 2 to 5 p.m. Eastern Standard Time. Let's see. Yeah, thanks for checking out. Yeah, Cross says I saw that tower video as well. It looks amazing. Yeah, thanks. I'm currently doing the video editing that explains how to assemble the tower because I've provided the blueprints for free so anybody can assemble this power tower in their world. But I haven't built the explanation yet on how to explain to people how to build it. That's what I'm working on right now. Oh, unfortunately, Cross, this is like the only time I can play right now is on stream. I'm so busy off stream doing other things. I just don't have time to play anymore, Cross. I do apologize. Um,
Okay, like that. All right, and now what I'm going to do is I'm going to cut.
yeah, no worries. Thanks, Cross. I appreciate that. Uh, yeah. So if if you go to my if you go to my Twitch page or Twitch about page, you can click on read my books. If you click on that link, it'll take you to all my links, and one of the links will say Satisfactory Blueprints. I believe in the YouTube video with my name Jakes, who interviewed me, he pinned a comment in his comment section that also provides that same bio link where you can check out. I don't think I put the link in the YouTube channel yet, though. I do apologize. Actually, wait, hold on. Let me see if I can put the link in here in chat. I think I can do that. It should be fine. Give me a second, Cross. I'll put it in chat. Make it easier for you. Other stuff that I'm working on are my books. I'm writing science fantasy books, and it's going to be a very big book series. of at least 12 books, and my job is to actually complete that project. It's probably going to take me like 10 years, and it's going to take me a while to build a following for that and to promote it and to get it. Because my ultimate goal is to get my book series into animation. And I'm actually role playing as one of the characters in the book series, Uncle Samael. I did reach out to my VTuber artist who designed my VTuber model that you're currently viewing right now. She's actually working on drawing up 3 uh, streaming background scenes for me for scene transitions like starting soon or be right back or ending stream. So I'm super excited for those. So we'll see how those go.
New backgrounds, huh?
Quiet Phil. Yes, Cross. So Cross says, but how do I use them? Do not know the process. Yes, that's exactly what I'm trying to do right now, Cross. I don't know if you can see my stream, but I have DaVinci Resolve up right now, and I'm doing video editing. I'm video editing the video that explains how to assemble the blueprints so that anybody can watch the video and understand how to assemble the blueprints. But I'm more than happy to also jump into your world and help you assemble them as well. That's totally fine. Yep. Yeah, no worries, Cross. I appreciate that. Thank you. So yeah, I just provided the link, my bio link that has all my links on it, Cross, for your convenience. And now we're going to transition to this. And now we're going to run. We're going to delete this. Now the power should be transmitting to the reactor above. And now we're going to transition to the next part of this tutorial regarding the harmonic balancers. Okay, Cross says followed on Twitch and subbed on YouTube. Thanks, Cross. I really appreciate that. Thank you. There are a there are So right now, Cross. So in a previous live stream or 2 live streams, I went through the process of demoing the entire construction of the blueprints, and you can actually check out those previous live streams on my YouTube channel. I've already uploaded them, but I'm going through the raw footage and I'm editing it out and I'm cutting out all of the long pauses or meanderings or other things that kind of slow down the video. That's what I'm trying to do right now. I'm trying to tighten it down to something that's much more digestible. Unfortunately, I don't think I'm doing enough editing because we're already almost an hour into this after editing and it still feels too long. But this is also the first time I've ever done video editing before, so I know it's already going to be bad anyway. There are a total of 14
First
different.
time editing and
All
you're
right, Phil, be
already
quiet. Cross says I will do them when I come back from work at 6 a.m. for me, and I got to leave for work at 8 a.m. No worries, Cross. No worries. I appreciate you hanging out. Balancer blueprints. Transmitting to the reactor above. And now we're going to transition to the next part of this tutorial regarding the harmonic balancers. Oh, that's right, we're going to delete this. And you just have to worry about all the external stuff that's happening. All right, so after connecting all the belts, I'm going to connect the power between the floors. So I'm going to connect these two ground outlets to go to like this. Now the power should be transmitting to the reactor above. And now we're going to transition to the next part of this tutorial regarding the harmonic balancers. There are a total of 14 different harmonic balancer blueprints. And they are optional. You do not need to plug them in order for the nuclear plant to turn. Alright, Cross says, being good or bad does not matter. You do something once and the next time you do it a little better. Soon you'll do everything great. This is how we grow and learn. Do not worry about the result. Do your best. Thanks, Cross. I really appreciate that. That is a life lesson that I still need to learn. On. However, I strongly recommend you use them because all 15 reactors are connected in a linear manifold, and the uranium rods coming down the stack have to fill up the individual buffers in each of these reactors, which means it could take up to on the order of 10 hours before all the reactors turn on, which is a very long process to wait. If you want this to go much faster, use the harmonic balancer blueprints. They speed up the startup time of all the reactors from several hours to several minutes. And I will demonstrate an example of how to connect those. So by default, you already have this built-in belt right here that automatically pulls a uranium rod coming down the stack and feeds it into the reactor here, and then any overflow of rods then continue down the stack to feed the other reactors below. But I don't want to do that because that's going to take a long time. So what I'm going to do is I'm going to use the harmonic balancers. However, they have to be done in numerical order. So there is no harmonic balancer number 1 because it's redundant. This individual line right here on the bottom reactor is already a harmonic balancer number 1. So you don't need to include that as a blueprint here. However, as we go up the stack, we do need a second balancer, and we're going to include the second balancer here. So this is harmonic balancer number 2. I'm going to set this to auto connect to the blueprint so we get alignment here. And I'm going to position my mouse. Sorry, let me grab the blueprint again. Where is it? So notice how I can't directly get the blueprint to go inside the reactor blueprint that I'm currently looking at forward. I can only place it above or below. But if I move below, if I point below to the first reactor and then press H, it does move it into the second reactor above. And that's how you have to place them. You have to look either above or below the blueprint you're looking. Give me a second, Cross, and Cross says, what are the resource requirements for this blueprints? How much power is it? Okay, so that's a good question. So, Phil, don't talk. The total produced power is 90,000 megawatts. And if you give me a minute, I will show you. I'll show you the resource requirements. Sorry, my VTuber model is dead right now. The camera stopped working. That happens sometimes, unfortunately. It's live streams. That's why my VTuber model is frozen right now. Alright, I need to pull up the document so I can show you. Okay, so this was the original document that I tried to type up. By the way, this is what it looks like. This is a pretty cool picture I took. It's got a little rainbow, and this is the power tower. And I built this monorail to hug around the tower because you need like 24 freight cars worth of items to build this entire stack. So I'm literally wrapping the train around the tower, and I'm running back and forth between the train and the stack to keep building it because I can't hold all the items in my inventory at once.
24?
Quiet, Phil. Okay, so these are all the blueprints, and so there's 10 blueprints to assemble the tower plus uh, 2 more blueprints for the water extractors. But these blueprints have duplicates, and the duplicates are for the X value here. So X15 means there's 15 of these blueprints. You have to stack on top of each other. So putting everything together, this is roughly how much items you need to assemble everything. You do need 628 power shards, and I was able to get all of the power shards that I needed by picking up all the slugs that I needed. I don't remember how many slugs this is, but it's not too bad. I think it's um, like I guess I don't know. It would be like it's it's like 60 purple slugs, roughly speaking. And that's assuming that you're using the Sumer sloops to double the number of shards per slug. I was able to grab all of those in a legitimate playthrough. You do need standard stuff like supercomputers, turbo motors, fused frames. You do need those. You need cooling systems, but not you don't need many of those because those are only for the reactors and the particle accelerators. The thing that is massive though are the heavy modular frames. Okay, so Cross says, "Oh, not to build it. I have all these. I've already I have all these already. I finished the game. I meant the inputs. Oh, the inputs. Okay. Yep. I have a picture for that. Let's see. Here it is. So there's a blueprint that I provide to you called the input display instructions, and it just tells you how much resource you need. So you need 300 uranium to produce 90,000 megawatts, and you need 450 sulfur, 300 iron, 300 deuterium, 300 copper, 300 raw crystal, 120 bauxite, and 780 lime. However, these are slightly over the true value, and if you look at the power plant on the return side, where there's residue that goes into an awesome sink, um, you actually get a little bit left over for these, which you can recover and use for something else. I'm trying to see if I have a picture of that. Yeah, so here's the awesome sinks that collect all the returned ore that wasn't used, which isn't much. It's only small amounts of it. Because the reason why we have leftover ore is because it's very difficult to build limiters that exactly limit the value that you want. That's really hard to do. But what you could do is build a feedback loop that takes all the return ores and moves them back onto the input ores, and that'll actually give you the exact amount that the factory needs. You also need 32 belts for the water lines. So there's 16 Mark V belts where you are giving packaged water to the tower, and then you are returning 180 empty. Sorry, you're returning 16 lines of empty canisters back to the packagers that you connected to. Um, and all of this is explained in this tutorial video that I'm trying to uh, do some editing on right now. So does that make sense? Looking at in order to get them to connect to be
Those
positioned
16
properly.
lines of canisters
Quiet,
sound like
Phil.
a
Um, yeah, feel free to ask me any more questions that you have. And again, I'm using the blueprint auto connect placement here to force it into the position that I want it to. I also included these little braided cable nubs here for helping verifying alignment. So you want this braided cable on this, right next to this floor cover, and then you want this braided cable on this electrical ground outlet. So that helps with verifying by eye that those are in the right placement. That means that this harmonic balancer is in the correct spot. There is clipping here that's happening. So the harmonic balancer is clipping into the reactor, but that's fine. I encased everything in concrete, so you don't see any clipping of moving parts. So it looks like it's embedded in the reactor itself. All right, Cross says another question: is this scalable? Like, I am making 300,000 power right now. Can do around 4,000 if I turn on everything. Do you think we can shard this and scale this to use more resources? I'm not sure what you mean, Cross. So everything that you're assembling, or all the factory buildings and the reactors are already, they already have power shards in them, and they're maxed out as much as I can make them. So uh, yeah. Also, you're producing way more power right now than what this reactor would give you. This plant only gives you 90,000 megawatts, so you're already producing way more than that right now. You're producing 300,000 megawatts. The purpose of these blueprints was just to help players transition out of phase 3. Um, So it sounds like you're building everything after phase 4. Okay, Cross says, like, if I want to use 600 uranium, can I still keep the same tower size? No, you would have to build a separate tower for for the other 300 uranium. Um, yeah. Okay, Cross says, or do I need to make two separate towers for this? Yes, you need to make two separate towers for the 600. Yeah, because we've already maxed out the power shards. Also, I would like to add, Cross, that this tower is actually really tall. It's 1.5 kilometers tall, and it's only 500 meters below the skybox. So there's very little room for extending the size of this thing any further. Like, if I didn't use the power shards, there was no way that this plant would have been able to fit in the skybox. Um, And I would also like to add that you cannot do the same thing with rocket fuel power. If you tried to build a if you tried to build an 84,000 megawatt rocket fuel power tower using 600 crude oil, there's no way that'll fit in the skybox, even if you use power shards. Okay, Cross says, now I am eagerly waiting for the video. I will make it and you will be able to help me assemble it. In my world, it would be fun. Yeah, definitely. For some reason, Cross, I don't know what happened, but I actually reached out to multiple people across multiple platforms, asking people like, hey, I'm looking for beta testers for these blueprints. And nobody's ever gotten back to me on feedback. I'm not even sure anybody used them, to be honest. And that was the whole point of building these, was to give them to the community. So I don't know. Either people just weren't interested or they were too intimidated. I'm not sure which one it was. Also, that's
Maybe
totally
they just
fine.
didn't have 24 freight cars of materials
All right,
just
Phil. I
lying
need you to
around.
be quiet so I can listen to the video. And then I'm going to commit. And then I'm going to put that there. And then the next thing I'm going to do is I'm going to remove this line that connects the rods from the external line to the internal lines. And I'm going to then connect the rods to the balancer now. And the number 2 in harmonic balancer 2 means. Okay, Cross says, I am up. I have no one to play this game with. I got like a million friends playing Counter Strike and Dota, so we can have some fun assembling this. Yeah, no, that'd be great, Cross. Definitely. Means that half of the rods are going to split off and go here into the reactor, and then the other half is going to get split off and go to the reactor below. That's why it's called a harmonic balancer. Harmonic just means you take 1 over the integer to get the ratio split on this line. Okay? And I recommend installing the harmonic balancers before you set up all the reactors, because it's just much easier to see what you're doing instead of having to, be inside and kind of cramped in here trying to connect everything that way. Okay. Now, for a visual demonstration, I actually have a demo over here to demonstrate the setup of harmonic balancers. So I'll actually demonstrate that for you. So what I've done here is I've lined up all the harmonic balancers in a linear manifold, but they're laid out horizontally. And I did this for demonstration purposes because it's very hard to see what the harmonic balancers are doing inside of the power tower, because they're embedded inside the blueprints and you can't see what is going on from the outside. So I literally laid them out here so that we could see what they're doing. The other thing that I did was I removed all of the concrete that's concealing them so that we can actually see what is happening. Now again, to explain the function of this, the way this works is alright, Cross says, let me know when you can play. I gotta rush now. I got a meeting in a different city today. I have not slept in 2 days, so I'll take a bath and chug a Monster Ultra and dive. So see you, mate. And please take care of yourself. Yeah, Cross, and you as well. Thanks for hanging out. This is harmonic balancer 15. So that means that 1 over 15 of the rods are going to go into this reactor here. This is a fake reactor. And then 14 out of 15 of the rods are they're going to go down to the stack below. This is, so that again, this is 15, this is harmonic balancer 14.
So that means 1 out of 14 of the rods goes into the this fake reactor right here. And then 13 out of 14 then go down the line to this one, to harmonic balancer 13, and their pattern repeats. So you keep creating these little fractions of divisions, and this is how you make sure that all the reactors in a linear manifold get even distribution amounts of rods. Not only will this give you a faster startup time for the reactors, going from waiting to several hours to several minutes, but the other added benefit to this is that the radiation at the bottom of the stack is dramatically reduced. There's almost no radiation at the bottom of the stack because there's only at most one rod in the buffer, because we're evenly feeding them using these balancers. So I put these little lifts here to catch all the excess rods in this demonstration, and I have a total of 75 rods here in this buffer. So I'm going to connect this buffer into this 15. So this storage container is simulating the production of rods above the stack, coming down the stack, and then feeding into these little fake reactors here. So again, if I have 75 rods to start with in a 15 harmonic balancer setup, that means each of these reactors should get exactly 5 rods in total. Okay, because 75 divided by 5 is 15. So let's verify that and see if that actually happens. Alright, so what I'm going to do is I'm going to connect this here, and then we're going to see the magic happen. So as you can see, a lot of the rods are just passing through, and only a small amount of them are actually going into the lifts as we go down this linear manifold of harmonic balancers. Harmonic balancer 5. Alright, so let's verify. Do we get 5 in each of these lifts? Oh, we got 6. Oh, I forgot. My bad. I forgot to include this lift. Sorry, this is fine. So this is totally fine. So there's supposed to be 5 here and 5 here, but because I forgot to include this lift, the 5th one and this one went into this one. But that's fine. This should totally work just fine. There's 5 there, 5 there, 5 there. Okay, that's 5. That's 5. That's 5. That's 5. 5. 5. 5, 5, 5, and 5. So that shows that this demonstration works, that these harmonic balancers do what appears to be the impossible. They perfectly load balance a linear manifold of reactors. So this is a substantial win for us. That's why I strongly recommend that you actually use these in this stack. This helps substantially with wait time and radiation as well near the bottom of the stack. Alright, looks like the power went out somewhere. Alright, so now we are going to go to another seed transition, and we're going to cut out perfectly load balance a linear manifold of reactors. So this is a substantial win for us. That's why I strongly recommend that you actually use these in this stack. This helps substantially with wait time and radiation as well near the bottom of the stack. And radiation as well. This helps substantially with wait time and radiation as well near the bottom of the stack. Alright, looks like the power went out. There's a lot of them. This is gonna. Alright, and now. Alright, I need to add a new. Alright, so I just added a new video to this thing.
Oh, great. Just what that bloated masterpiece needed. More footage to trim. So, what's this new addition bringing to the table? With 5,000 hours? I might hit 5,000 hours just waiting for Mega Spire. A real session until we're towering over the landscape.
Alright, so we are continuing where we were. Alright, so we are continuing. And radiation is. We're continuing where we left off on finishing up substantially with wait time and radiation is. We're continuing where we left off on finishing up the nuclear power dash continuing where we left off on time and time and radiation is now and radiation is is
Thing. It's not a real session until we're towering.
so we are continuing substantially with wait time and radiation is. Alright, so we are continuing where we left off on finishing up the nuclear power dash 01L dash X15 blueprints. These are the nuclear reactor blueprints. Reactor blueprints.
Back at the Megaspire. Glad to see you're finally tackling the nuclear power 01LX15 again, because nothing says professional engineer like a giant radioactive skyscraper looming over the ocean.
Let's see if we can actually get these reactors finished without the whole grid throwing a tantrum this time.
Okay.
That huge red blueprint is quite. Take a look. I'm guessing the nuclear power plant. Golden puzzle piece from the.
Alright, we're gonna fast forward through all this boring stuff, Phil.
Finally, I was starting to think I'd need a Monster Ultra myself just to sit through the raw footage. Scrub away. Finally hits the Halenoff.
6.
And you're still calling me Bill. At this rate, the factory is going to be finished before your brain is. Just try not to wire the 15th one into the ocean, or we're both going to have a very short stream.
Alright, 12. 11. 10. 9. 8. 7. 6. 5. 4. 3. 2. Alright, so that's all. Okay. Alright. Yeah. Power in this stack. This helps substantially with wait time and radiation as Alright, so we are continuing where we left off on finishing up the nuclear power dash 01L dash X15 blueprints. These are the nuclear reactor blueprints. Alright, so that's all 15 harmonic balancers put in. We did it, Phil.
6 is.
Alright, so that's all 15 harmonic balancers put in. Put in. We did it, Phil.
6 balancers down, and you're still standing? I'm genuinely impressed, though mostly because I thought you had passed out on your keyboard by 4.
Alright, we did. And now we're gonna move them in. And now and now we're on. And now we're on. This helps substantially with wait time and radiation as Alright, so we are continuing where we left off on finishing up the nuclear power dash 01L dash X15 blueprints. These are the nuclear reactor blueprints. Alright, so that's all 15 harmonic balancers put in.
And now we're going to move on to the next set of blueprints called the Nuclear Power 02L X2 blueprints. 02L stands for the second subset of blueprints, and X2 means that there are two duplicates of these blueprints we have to place down, and these are the particle accelerator blueprints.
Moving on to
These are the particle accelerator blueprints. I'm going to check alignment now. Stands for the second subset of blueprints, and X2 means that there are two duplicates of these blueprints we have to place down, and these are the particle accelerator blueprints. I'm going to check alignment here. Okay, that looks good. Gonna connect the power. And then I'm going to connect all of these lifts together.
connecting power and lifts on no sleep? I'd say that's a recipe for a blackout. But your grid's already a 90,000 megawatt ego trip, so what's the worst that could happen? Just try not to wire yourself into the circuit while you're at it.
And we're going to connect these different lifts together. These are the water directors.
Water extractors? More like a
Water directors. So water directors.
water extractors? More like a liquid logistics nightmare. Good luck getting those lifts to play nice. FICSIT didn't exactly design this world for vertical sanity.
Oops, I made a mistake. I forgot to connect these lifts together.
Mistakes happen, especially around here.
Alright, so that should be good now. Alright, so that should be good now. We have items going up the line, but going up the line, so that's good. Okay, so we're gonna build the lines. That's we have we have we have
Got it.
and we're gonna connect these different lifts together. These are the water
reactors. We have items going up the line, so that's good. Okay, so we're gonna build the second particle accelerator.
A second particle accelerator? At this rate, you're going to create a black hole before you even finish your first coffee of the day. Just make sure the power grid doesn't decide to give up the ghost when you flip the switch.
Alright, we just connected the
You're
particle accelerator.
a second particle accelerator? At this rate, you're going to create a black hole before you even finish your first coffee of the day. Just make sure the power grid doesn't decide to give up the ghost when you flip the switch.
Alright, we just connected the Alright, we just Alright, we have items going up the line, so that's good. Okay, so we're gonna build the second particle accelerator. Alright, we just connected the power, and now we're going to connect all these lifts.
Power's on, and Power's on, Power's on, and we're building the second accelerator. Looks like the ego trip is officially hitting its stride. Just try not to blow the fuse before you manage the coffee.
Alright. Yeah, what? Alright. 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 Alright, we just connected the power, and now we're going to connect all these lifts. Alright. And then the next thing we're going to do is we're going to disable the non-fissile uranium for the particle accelerator that's on the bottom here. What we're going to do is we're going to turn off the left side of the programmable splitter. This will prevent the non-fissile uranium from continuing to go down the stack because there's no reason for it to do that. Okay, so there you go.
Smart move on the program. Smart ROMs. Smart move on the programmable splitter. No sense in having non-fissile uranium clogging up the stack.
Okay. Lose. And now on. And now. Alright. And then the next thing we're going to do is we're going to disable the non-fissile uranium for the particle accelerator that's on the bottom here. What we're going to do is we're going to turn off the left side of the programmable splitter. This will prevent the non-fissile uranium from continuing to go down the stack because there's no reason for it to do that. Okay, so there you go. And
And now we're going to move on to the nuclear power -03L-X4 blueprints. These are the oil blueprints, and there are 4 of them that we have to connect in sequence.
Four blueprints for one oil line? Makes it definitely
Okay, I'm going to lock it out automatic. Go down the stack because there's no reason for it to do that. Okay, so there you go. And now we're going to move on to the nuclear power -03L-X4 blueprints. These are the oil blueprints, and there are 4 of them that we have to connect in sequence. Okay, I'm going to lock it in and I'm going to check alignment here. Okay, that looks good. Then I'm going to connect the power. And then I am going to connect the lifts.
connecting power and lifts on those 03. Connecting power and lifts on those 03. For someone running on 0 caffeine, Uncle Samuel. Just try not to cross the wires, or we're going to have a 90,000 megawatt paperweight on our hands.
Looks good. Then I'm going to connect the power. And then I am going to connect the lifts. Alright, so that's looking good. Good. Alright, so over next again. We're going to do this. Alright, third. One more. Check the power, now I'm going to do this. Now I'm going to do the fourth one. Now, next time we do because I
Masterpiece is going to have a very messy heart attack.
and now I'm going to, and then it's mine. And now I'm going to, now I'm going to, and then we're going to connect the 4th and final oil blueprint.
The
Now I'm going to, and then we're going to connect the fourth and final oil blueprint. Now, next we do and then we're going to connect the fourth and final oil blueprint. Now, the next thing I'm going to do is place down the decoration, the top decor blueprint.
Placing the top decor now? Finally, some architectural flair to hide the functional chaos. Just try to snap it on straight, Bill. Nothing ruins a professional megastructure like a crooked hat.
Okay, so this is optional. Obviously, we don't want to have this top decor here later on because we still have more blueprints to stack on top of each other. The reason why I'm demonstrating putting this top decor during this intermediate progression stage is because what may happen down the road is because you have a finite amount of space in your inventory, you may not be able to fit all the parts to assemble all the blueprints all at once. And so what I recommend you do is every time you run away from the tower to grab more items into your pockets, before you go, I recommend putting down the top decor while you grab more parts, because the plant will continue to run and fill up all the internal buffers inside these buildings, and this will give you a faster startup time for when eventually the tower is complete. All the internal buffers hopefully will be finished filling up. Now it looks like filling up. Now it looks like there's a broken connection somewhere, so I'm gonna go find out where that is. Okay. Those are sorry on it. Alright, oh, it is already now. Is here. There is a much longer message. Okay, so yeah, will be finished filling up. Now, okay, so we are going to move on to the next set of blueprints. The tower is complete. All the internal buffers hopefully will be finished filling up. Now, okay, so we are going to move on to the next set of blueprints, which are the nuclear power -04L-X1 blueprints. I believe these are the steel blueprints, and there's only one of them that we have to build.
X1 blueprints. I believe these are the steel blueprints, and there's only one of them that we have to build.
What we're gonna do is we're gonna do the first one. Oh, I apologize. What?
The decoration blueprint. Oh, I apologize. This is not the steel blueprint. This is the aluminum blueprint. This is blueprint. This is the finished. Filling up now. Okay, so we are going to move on to the next set of blueprints, which are the nuclear power -04L-X1 blueprints. This is the aluminum blueprint. My bad. So we're gonna. So sorry. The -04L is the aluminum blueprint, and we're going to place that down. We're gonna check for alignment, and okay, it looks like there's a misalignment here, so I'm gonna nudge it into place, and that should now be in the correct slot.
Aluminum, huh?
Okay, I'm going to connect the power, and then I'm going to connect the lines here.
Good luck with the power lines. Hopefully, this blueprint actually. While your power grid is on life support, bold move. Bold move.
Going to connect the lines here.
Bold move. Let's see if that aluminum plan actually snaps into place, or if we're looking at another 90 minutes of industrial geometry stress.
Alright, and so now I'm going to put it line.
Case?
Right now,
One, there.
Industrial geometry stress.
Then I'm going to connect the lines here. Alright, so now I'm going to put in the top decoration so that I simulate running back down to grab more parts to build the next blueprint. And while I pretend to go grab more items from my pockets, we're gonna put in this decoration so that the factory can continue to run and fill up the internal buffers in the meantime to help speed up the time that it takes to turn on the entire plant. In the meantime to help speed up the time that it takes to turn on the entire plant.
Everything.
Okay. Alright, there. In the meantime to help speed up the time that it takes to turn on the entire plant. Alright, so the next blueprint is the nuclear power -05L-X. Alright, I'm gonna cut the stream early today. It's getting late for me and I have to get up early tomorrow for a possible career fair tomorrow. We will continue the video editing hopefully later streams, depending on other optional stuff that may happen. Um, so let me check this. I think Andrew is streaming tonight. Let me check.
Checking the competition, are we? If Andrew's on, at least you've got a place to lurk while you dream about career fairs.
Yep. Okay,
Good luck.
so Andrew is still streaming. We'll definitely raid his channel tonight.
Oh, look at you, being all supportive. Just don't let his productivity make your 42-minute bloat feel even heavier. Lead the way, Uncle Samuel.
So yeah, again, I really appreciate you guys hanging out tonight, and I'll catch you Thursday from 7 p.m. 10 p.m. Eastern Standard Time. Excuse me.
Thursday at 7 then. Try not to dream in Da Vinci Resolve timelines until then. See you at the raid.
It will crazily start killing performance. There's memory leaks that build up, and I don't know if they fully tackled those. So I would say that a lot of that lag is probably coming from that. If again, no expert here, but I feel yeah, for real. Yeah, Leo, they were trying to tackle that before 1.0 came out, and they were asking me if I could,
Look,
what's my
you've
largest save
teased
file so far, largest
interesting
times,
things
and we
twice
talked
now.
about that. So I
If
reached
it's
out to the
not a
community here
secret
and
sneak
gathered
peek
up
at the
everybody's
book
save files
series
and had
or
a
a
ton
clip of
of
this
time.
nuclear tower
And
actually
I'll
working,
ask them next
I
time we chat.
might
But
just have to stay
somebody and see if
sassy
that's
until
something that
Thursday.
they
What have you
whenever
got?
they'll tackle that. And then
Alright, so we're gonna raid BL Andrew 575.
A raid on
Alright,
Andrew?
take care. Have a wonderful night, and thank you so much for sticking around. See ya. Bye-bye.
It's just all about how well they can optimize it to make it just.
Later, Uncle Samuel.
Yeah, I would say a
Have
lot of
fun
your
with
time's
the
from that.
raid
There it
and
is.
try not to.
That name again sounds so familiar.
Alert. Fix-It approved raid incoming.